Yeah, this is a video to explain integration by parts. So at this stage in the game, you should have seen this formula. Now there might be some mystery as to where it came from, how it was developed, and this video is to try to clear that up. After that, I'm going to put some more videos up, just real short, quick videos of different examples of integration by parts that might be relative to relevant to the AP exam. So the example I'm going to use to show where this formula comes from is this. Sorry, let me change to the paintbrush. Integral of x cosine of x dx. And the first thing you should do is give this a shot with a simpler method like u substitution, and you'll find, I think, that it's rather difficult. So here we go. The first thing to recognize in getting this straightened out is this. If I look at sine of x plus x cosine of x, I know that that is the derivative of x sine x. And check for yourself. Take the derivative of x times sine x using the product rule and see that you do indeed get this function right here. Okay? So now what I'm going to do, knowing, this is also assuming that we've had the fundamental theorem, we know that the integral and the derivative undo each other in a manner of speaking. We get this. The integral of sine x dx plus the integral of x cosine x dx is equal to x sine x. Having taken the integral of that, we end up, it undoes each other, one another. So we have this. Now, looking at what we have, if I now just watch, bear with me for a minute, I'm going to subtract this whole thing off of the left, and what I'll end up with is this. The integral of x cosine of x dx, which is actually the original integral I want to take, equals x sine x minus the integral sine x dx. And this kind of embodies the whole idea of integration by parts. What we're doing is we're actually taking a difficult integral, this one, and we're turning it into a multiplication problem minus a simpler integral. So that's the whole point of this. Now let's just look. If we were to say this, let x be u and let sine be v. Okay? That would mean, according to this, what we would have is du, by taking the derivative, would just be 1 dx, and dv would be equal to the cosine of x dx. Now, pause the video, make sure you're okay with this. The reason is because v is equivalent to the sine of x, and the derivative of sine is cosine, so this is what I get when I have dv. Now, just looking at what we have here, this ends up becoming, if you go backwards, this section right here is just uv minus the integral of v du. Just doing a direct substitution, v du. And then looking across at on the other side of the equal sign, this is the integral of, if you look at it, what we have is u, that's just x, and cosine x dx is dv. So you can see where the formula came from, and I hope what you're seeing is this is kind of like the backwards product rule. So now let me just go through and actually do this problem. Let me scroll this up, get rid of that, and now I'll show you how it's actually done, pretending we didn't know the answer. So we would say this. The problem at hand is the integral of x cosine x dx. What I would do is I'd have to pick u, and in this case I'm going to let that be x, and then I would have to pick dv, and dv is going to be cosine x dx. And the reason I have to do that is because what I'm going back, just look back at the formula up here, right? We're trying to turn this into the integral of a function u dv, and that's going to be equal to these things over here. So we're required to pick u and dv, and from our choice of u and dv, we should be able to reduce this to a simpler integral according to the formula. Now, once we choose u and v, we're locked in. That means that du would have to be equal to 1 dx, and v Now, if dv was cosine, that must mean that I had to have differentiated sine to get it. So it's almost like I'm doing a simple integral right here to get back, and I end up with the fact that that's sine. Now, according to the formula, by integration by parts, it's u dv is equal to u v minus the integral of v du. Now, if I've chosen right, everything is going to work out nicely. Watch. Equals uv, so this times this, x sine x minus the integral of v du. So it's going to be sine x dx. And now what I have is x sine x is done, minus, I think it's fairly easy for us to know if I'm taking the antiderivative of sine of x, that means I must have had negative cosine x. And as with all anti-differentiation problems, I have plus c. So this becomes x sine x plus cosine x plus a constant. This is the answer to this antiderivative. So hopefully that clears up a little bit of the mystery as to where the formula comes from. Now you have to get practice at using it. And I'm going to put a few subsequent videos up there that show you how to use it and solve problems that are a little bit more difficult.